Marda. Today I will be talking about Coulomb's law. Coulomb's law basically states that the force of attraction or repulsion between 2-point stationary charges is directly proportional to the product of the magnitude of the charges and inversely proportional to the square of the distance between them. So I said that the force can be either attractive or it can be either repulsive. And this is quite obvious. If we have two plus charges, the force will be repulsive. And if we have, suppose we have one plus charge and one minus charge, or one minus charge and one plus charge, the force will be attractive. And if we have two charges of the same nature, plus plus or minus minus, the force would be repulsive. And this force is directly proportional to, let's say we have one point charge here. Let's say this point charge is Q1 and this is Q2. So the force is directly proportional to the product of the magnitude of the charges. It doesn't matter whether it's plus or minus, we just need to take its modulus. So that will be the magnitude of the charges, and this force is also inversely proportional. Suppose the distance is r, it is inversely proportional to the square of the distance between them. So combining these two equations, we get F is directly proportional to Q1 Q2 by r square, and F is equal to K Q1 Q2 upon r square. Here K is an electrostatic force constant. This is the electrostatic force, and K is equal to 1 upon 4 pi epsilon naught. So basically epsilon naught here is the permittivity of free space. So this is also F naught, you can say. This is the electrostatic force in free space. So basically the full formula which we get for the electrostatic force is so I just talked about that force is equal to K Q1 Q2 upon r square, where K is equal to 1 upon 4 pi epsilon naught. We are just talking about free space here, therefore we are using epsilon naught. So if you were to calculate the units and dimensions of K, which are considered as very important, so from here we can see that K is nothing but Fr square over Q1 Q2. So we know that the unit of force is Newton, the unit of radius, which is nothing but length, it is meter square, upon the unit of charge is actually Coulomb, and we denote it by the letter C. So the units of K, which is the electrostatic force constant, become Newton meter square per Coulomb square, or Newton meter to C minus 2 inverse. Now the dimension, these are the units of K, and now the dimensions of K. We know that the dimensions of force are mLT minus 2. We also know that the dimensions of r square are L square. The dimensions of r square is L square, and since here a new dimensional, you can say we basically know three here, ml, m, l and t. But we don't have anything to represent Q1 and Q2. But we know that the current is actually the rate of flow of charge. And so from here we get that this charge is actually I into T. And we get that the dimensions of Q, the charge, is nothing but dimensions of I is A, that is ampere, and time is T. So dimensions of Q1 into Q2 is A square T square, because there are two charges here. Here there was only one charge. Now here there are two charges. So the dimensions of K we can calculate. Force is mLT minus 2. Radius is L square. Q1 Q2 is A square T square. So this becomes M1 L cubed T minus 2 and minus 2, this is A square T square, minus 2 minus 2 minus 4 M1 L cubed T minus 4, and this is A minus 2. So these are the dimensions of K. I'll again repeat it. Force, which is MLT minus 2, radius squared, which is L squared, and Q1 Q2, which is A square T square. So M is alone here, so M1 L cubed, L1 plus L1 into L2 is L cubed, and T minus 2, and this is T squared, and write it properly. A square T square. Yeah. This is T squared, so T minus 2 and 2 goes up, so it becomes T raised minus 4, and this is A raised minus 2. So these are the dimensions. And these are the units of the electrostatic force constant, which is K. So now let's talk about E naught. That was the permittivity of free space. I told you all that F is equal to 1 upon 4 pi epsilon naught. This is epsilon naught, not E naught, my bad. Q1 Q2 upon R square. So now when we talk about the units and dimensions for epsilon naught, we can see that epsilon naught is nothing but Q1 Q2 over 4 pi R square F. Right? Yeah. Over 4 pi R square F. So now if we talk about its unit first, so the units basically they become Q1 Q2 product of the magnitude of the charges, Coulomb square, over 4 pi has no units, R square is meter square, and force is Newton. So this units become C2m minus 2n minus 1, or yeah, these are the units for epsilon naught. Once again, force is equal to 1 upon 4 pi epsilon naught Q1 Q2 by R square. So when we bring epsilon naught to this side, we get Q1 Q2 upon 4 pi R square, force comes down, and then we just calculate the units. Now for the dimensions of epsilon naught, we know that Q1 Q2 is the dimensions of epsilon naught. The dimensions of Q1 and Q2 is A square T square whole over. 4 pi has again no dimensions. R square dimensions L square, and this is force is MLT minus 2. So now when we calculate this, we get M is actually, this is M minus 1, this is L minus 3, this is T raised 4, and this is A square. So these are the dimensions, and these are the units for E naught, epsilon naught, and epsilon naught is the electrical permittivity of free space. Now when we talk about relative permittivity of a medium, we know that F naught here, we know, I'll just first write the formula only. The relative permittivity of a medium, ER, is E upon E naught. E is the permittivity of that medium, and E naught is the electrical permittivity of free space. So we know that F naught is 1 upon 4 pi epsilon naught Q1 Q2 over R squared, and F, just F is of any medium we are supposing, the Coulomb, this is the electrostatic force in any medium, that is 1 upon 4 pi epsilon Q1 Q2 over R square. Now when we divide these two equations, we'll get F naught over F as this will just get cancelled, and then this will go up, so it will be E upon epsilon naught. And epsilon upon epsilon naught is nothing but ER. So F naught is equal to epsilon R times of F. Epsilon R is actually F naught upon F. So this is the relative permittivity of free space, and this is the ratio of the electrostatic force in this is the relative permittivity of a medium, and it is the ratio of the electrostatic force in free space, and this is the electrostatic force in a particular medium. Now you can see that it will have no dimensions or units. It is a unitless and dimensionless quantity, because in the numerator and denominator both are forces, so they will just cancel out each other. Now let us see some applications of Coulomb's law. Suppose I have a ball here. It is dropping. Somebody has dropped a ball, let's say from a building, and let's say there is another ball here. This ball is A, this ball is B. Let's say this ball is a sphere and it is positively charged. So the force acting on it, because it is falling downwards, will be mg. Now if suppose we want to stop this ball, so we will have to introduce a new force. Let's say we introduce a new sphere here, ball B, and that is also positively charged. Let's say this is plus q1 charge, and this is, let's say, plus q2 charge, and this is plus q1 charge. So since both of these charges are of the same nature, plus and plus, this ball will actually repel this ball. So a force will act in the opposite direction, and this is the F electrostatic force. So to stop the ball from falling, we can just equate the electrostatic force to the weight of the ball A. M is the mass of the ball A. So F electrostatic force is 1 by 4 pi epsilon naught Q1 Q2 over R square, that is equal to mg. If suppose we were to calculate the mass of the ball, so we would get that mass is actually, mg is Q1 Q2 over 4 pi epsilon naught R square. So mass will be Q1 Q2 4 pi epsilon naught R square times of g. Now we will be given with the values of Q1. Let's say Q1 can be suppose plus 10 coulombs, and Q2 can be, let's say, plus 20 coulombs. So to calculate mass, we will just plug in these values and we'll get the answer. Now let's say there is a particle and it is moving in a circular motion like this. Let's say the particle is here at point P. Its velocity will always be tangential. Let's say this velocity is v, and let's say this particle has a, let's say this is actually a charge only, a charged particle, and it has a charge of plus q, and plus q1 we can say, and at the center there is another particle which has a charge of minus q2 we can say. So since these charges are of opposite nature, they will attract each other. So this point charge will be attracted towards this charge here. The charge at P will be attracted towards the charge at O. So, and this is also the direction of the centripetal force. Centripetal force is mv square upon r, or m omega square r. And this centripetal force is equal to the electrostatic force, like this. So F electrostatic force is equal to the centripetal force. So electrostatic force is 1 upon 4 pi epsilon naught Q1 Q2. We are not considering the signs, just taking the modulus, the magnitude of the charges, over, let's say this is r square. Let's say this distance is the radius of the circle r. This is equal to mv square upon r. So from here we can calculate anything. Suppose let's say we were to calculate the kinetic energy. So kinetic energy's formula is half mv squared. So first we need to eliminate r from here. We can see that r and r get cancelled. So mv squared is nothing but 1 upon 4 pi epsilon naught q1 q2 over r, and we'll just bring the half in here, multiply half to both equations, we will get 1 by 2 times 1 by 4 pi epsilon naught q1 q2 upon r squared. So this will be the kinetic energy. Now let's say we were to calculate, let's say the time period. Suppose time period t, we know that omega is equal to 2 pi upon capital T. So, and we also know that F electrostatic is F centripetal, and this is 1 upon 4 pi epsilon naught q1 q2 upon r square, and this is equal to the centripetal m omega square r. We are not using mv square by r, we are using m omega square r here because we need to calculate the time period, and time period is related to omega. So now we can just q1 q2 upon 4 pi epsilon naught r, this r, it will go in the denominator, so it will become r cubed is equal to, and mass will also go in the denominator, this is omega squared. Just substitute omega for 2 pi upon capital T, so we'll get 2 pi upon capital T whole squared is equal to q1 q2 upon 4 pi epsilon naught r cubed m. Yeah, and this is 4 pi square t square is equal to q1 q2 upon 4 pi epsilon naught r cube m. And I'll just rub this. So from here I'm just writing over here. So we need to calculate the time period, right? So when we cross multiply, we get t square q1 q2 is equal to 4 pi square into this thing, so we will get 16 pi cube epsilon naught r cube m. I'm just rechecking. 16 pi cube epsilon naught r cube m, right? So t square is 16 pi cube epsilon naught r cube m upon q1 q2. Take the square root, so we will get 16 pi cube epsilon naught r cube m over q1 q2, and this is under the square root. So this is the time period. We can calculate anything actually from here. We can calculate the frequency also, that is omega is equal to 2 pi nu. We just plug in the value of omega as frequency, or we also know that frequency is nothing but 1 upon time period, so this will just get reverse inverse of it. The frequency will be just 1 upon t. So let's say another example here of its Coulomb's law's application. Let's say two pendulums are hanging very close to each other. Suppose they are touching each other, and both are of same charges, plus q and plus q. So what will happen is that these charges will repel each other, so the pendulums will go like this. Let's say this is its center. Let's say this is L, this length, and length will obviously remain the same. So length is L here. This is 90, this is 90. Let's say this is theta angle, this is also theta then. Now this is theta, so this will also be theta. This is tension T, and this is T cos theta, and this will be T sin theta. This is plus q charge, this is also plus q charge, same charges, same magnitude. So these charges would both repel each other. So this would be F electrostatic, and this is Mg. So from here we get our equations as F is equal to T sine theta and mg is equal to T cos theta. Now just dividing these two equations, we will get F upon mg is equal to T gets cancelled, sine theta upon cos theta is equal to tan theta, and F is equal to mg tan theta. Now okay, so 1 upon 4 pi epsilon naught q1 q2 upon r squared is equal to m times mg tan theta. Let's say this is A, this is O, this is B, and this is C. So we know that by geometry we know that AB is twice of AC, and we also know that to calculate tan theta is nothing but perpendicular upon base, but we don't have either of them. So let's say this and this R is nothing but AC. So because R is the distance between the two charges, right? So R is AC. So this is AC whole squared. So this is 1 upon 4 pi epsilon naught q1 q2 upon. Now to calculate AC, we basically first need AB, and AB is sine theta. So sine theta is equal to perpendicular upon hypotenuse. So sine theta is equal to AB upon L. So AB is equal to L sine theta, and therefore AC is equal to 2L sine theta. So AC squared would be 4L square sine square theta, and this is equal to mg tan theta. So from here the charges are of same, so q1 q2 is nothing but q squared, and we need to calculate the charge only, both the charges. So q squared is equal to, this is 16 pi epsilon naught L square sine square theta mg tan theta. I just cross multiplied, so q squared is equal to 16 pi epsilon naught L square sine square theta mg tan theta. So q would be the square root of this 16 pi epsilon naught L square sine square theta mg tan theta. Let us say we have a triangle here, an equilateral triangle. This is plus q charge here, this is plus q charge here, this is plus q charge here. Point A, point B, point C. ABC is an equilateral triangle of side L. At the centroid of this triangle, let's say there is a charge plus capital Q. We need to calculate the net force on this plus capital Q charge. So we know that all of the charges are of same nature, so all will repel. So force on G due to A would go like this. This is the force on point G due to the point A charge. This would be the force on G due to B, and this would be the force. The force always acts along the direction. So this is the line here, and the force will act along this line. So this force here would be force on G due to C. Now when we resolve these components, this is our two-dimensional plane. So this is force on G due to A, this is force on G due to B, and this is the force on G due to C. So this is 30, this is 90, this is 60, So basically this will be 30 degrees, yeah, and this would also be 30 degrees, yeah. So this component right here, the horizontal component would be FGB cos 30, the vertical one would be FGB sin 30, and not, yeah, I'll just write it, sin 30. This is FGC cos 30, and along one another force here, the vertical force would be FGC sin 30. So the net force on this capital Q charge is actually F net on Q would actually be the force on G due to A plus the force on G due to B plus the force on G due to C. Now force on G due to A is this force, and force on G due to A is nothing but K G due to A, right? One is capital Q, another is small q. K Q1 Q2 upon R square. So here AG would be equal to L by root 3. So R squared would be L by root 3 whole squared, and this is in the downward direction, so minus J cap, and this would be 3 will go up, so 3KQQ upon L square minus J cap, right? So the force on G due to B would be FGB cos theta plus FGB sin theta. So FGB cos theta, FGB cos 30 plus FGB sin 30. I forgot to add the direction. FGB cos 30 is towards positive I cap plus FGB sin 30 is towards positive J cap. FGB is actually, this is G and this is B, right? So this would be KQQ upon, again, BG here is also L by root 3 since it is an equilateral triangle. So L by root 3 whole squared, again the same thing, so 3KQQ upon L square. Cos 30 is root 3 by 2 I cap plus, now this is 3KQQ upon L square, sin 30 is 1 upon 2, and this is J cap, yeah, and force on G due to, now we need to calculate the force on G due to C, so that would be equal to FGC cos theta plus FGC sin 30. So this is FGC cos 30, and this is towards the negative x direction, so minus of I cap plus FGC sin 30 towards the positive y direction, so plus of J cap, and FGC is G due to C is KQQ upon, again same thing, GC here is also L upon root 3, so 3KQQ upon L square. Cos 30 is root 3 upon 2 minus of I cap plus FGC 3KQQ over L squared. Sin 30 is 1 by 2, and this is positive J cap. So I'll I don't have space, I'll just write the main equations here again. So that would be F net is FGA. FGA is this 3KQQ over L square minus of J cap plus FGB. FGB is this. This is 3 times root 3 KQQ over 2L square I cap plus 3 KQQ upon 2L square J cap plus now the force on G due to C, which is this 3 root 3 KQQ over 2L square minus I cap plus now this 3 KQQ over 2L square positive J cap. Okay, yeah. So now let's see what is getting cancelled here. Minus I cap plus I cap, this gets cancelled. Now we are left with 3 times KQQ over L squared minus J cap plus, this would be actually 3, these two would just add, right, because positive J cap both are. So this would be 3 plus 3, 6, and 6 divided by 2, it would be 3 only. So 3KQQ over L squared, and this is J cap. So again minus J cap plus J cap gets cancelled and you get 0. So force is actually 0 newtons, and I'll tell you the reason for this. So we had a triangle and all charges were of the same nature and equal in magnitude. So when this is the situation, the force on the centroid would always be 0. Similarly, we can take another shape, let's say a square, plus Q plus Q plus Q plus Q. So the force at the center would always remain 0. If this is plus Q and this is, let's say, Q. This would always remain 0. This is plus Q. Why? Because this would repel in this direction, this would repel this capital Q charge in this direction, this would repel it in this direction, and this would repel it in this direction. So the vector sum of these two we will get as this, and the vector sum of these two we would get as this, and all will just nullify each other and we will get 0 newtons. That is all for Coulomb's law. I hope you all liked the video. Please like, share, comment and subscribe, and I'll see you all in the next one. Thank you.